Hi, Martha. Can you hear me? Uh, and hello, everyone. And I'm really very much looking forward to the question and answer session at the end. So the slide deck is good, but I'm very much looking forward to hearing what your questions are about heat pumps and maybe even start kind of thinking about your own particular house because it could be informing many other people's homes as well. So let me just get these controls going. So as far as what we're going to cover today, we're just going to do a brief introduction, how heat pumps work. We're going to talk about the different configuration options. We'll talk about some of the challenges or barriers. And then we'll also just kind of review all of the incentives, which in 2022, they got really good. In 2023, they're getting even better with the federal tax credits also coming into play. And just real quick about the company I work for, Abode Energy Management. The company, we're all, I think, at our heart, just like mostly a bunch of building scientists. So a lot of us have experience in like residential energy audits. Since kind of launching the company, which started off as just managing the contractors inside of the Mass Save program. So companies like HomeWorks Energy or Revise Energy or Nico. So we kind of oversee all the quality assurance that's happening in Mass Save. But then we started kind of branching out a little bit. So the first kind of initiative was running a training for design and build professionals about air source heat pumps, ground source heat pumps, solar PV, as well as solar thermal. And that really kind of like laid the groundwork for us understanding kind of how these technologies overlap with home performance. And home performance is just really, when I think about that, it's just really understanding how homes use and lose energy and what we could be doing in terms of modification to be reducing that. Other things since then, we've launched a handful of heat pump programs through a lot of different communities, now including Melrose. We're running the whole state of Connecticut's heat pump program. So we got a pretty good understanding of exactly what the Metro Boston heat pump contractor marketplace looks like, what is appropriate equipment, how most homes are performing, and the type of equipment that they're needing. So hopefully we can be a good resource for you to be kind of helping to hold your hand and serve in some ways as a middleman as you are pursuing decarbonizing your home, either all at once or over time. We'll hop past this slide just because Martha already did a bit of an introduction regarding kind of the initiatives going on in Melrose. So just to get started, like so for all of human history, we have been heating our habitats with setting things on fire. And, a long time ago, just our only option was sitting close to the fire to be warm. And then over time, we eventually came up with things like wood stoves or chimneys and fireplaces, and it got a little bit better. And then about 120 years ago, we invented these central heating systems and we stuck them down in the basements. But still, it's pretty much the same concept. You're just setting something on fire, and that is generating energy, or that is generating heat, and then it's being distributed throughout the home. So the problem with that is that we do have a bit of a climate emergency on our hands. So we are looking for a different way other than burning things to be able to create heat. And the best thing that we've come up with is a heat pump. And what it is, instead of setting something on fire to be generating heat inside of a structure, we're just going to be using electricity to move energy from one location to another. So it may seem like a wacky concept to think that there's like heat in the outside air in the wintertime, but we can even see this phenomenon happening in our home. So say, for example, your freezer. How does your freezer work? It doesn't work by, say, creating cold. It works by just taking heat inside of this box, which is freezing, and moving that energy to the outside, like your kitchen. Or hypothetically, just imagine a window air conditioner. It's just taking heat or energy inside of your home, and it's just moving it onto the outside of the home. And you may have not sat behind the back of your refrigerator and put your hand there and felt the heat, but probably most of you have either walked by a central air condenser, a central air system's compressor at the back of a window AC and feels hot on the other side, like there's hot air blowing at you. And that's just the heat pump moving energy from one location over to another. So heat pumps don't generate heat, they just move energy from one place over to another. So where does that heat come from? Well, in the wintertime, it's coming from the outside. So it may not seem like it. It may not seem like 0 degrees or -5 degrees, that there's a lot of energy in the air. But if you've ever been outside and it's -30, you know that -5 is a lot warmer than -30. So even on like bitterly cold days, there's still lots of energy in the outside air that could be captured and moved into your home. And same thing in the summertime. It's not adding cold into your home. It's just taking heat and taking moisture from inside your home, and it's just dumping it to the outside. So this slide's a little technical, but how heat pumps work, just know that there's always going to really be two different components of it. There's always going to be an outdoor unit as well as an indoor unit. And connecting those two different units isn't going to be air ducts. It's just going to be refrigerant lines. And what's going to happen is there's this equation. So as you like increase pressure, it equals increased temperature. So really what's happening is on the outdoor unit, it's say picking up the energy in the outdoor air. So say if it's 0 degrees outside, what's going to be happening is the outdoor unit is going to have, say, -30-degree refrigerant in it. Hot goes to cold. So say the 0-degree air is going into this -30-degree refrigerant, and eventually that refrigerant is going to be 0-degree refrigerant. And then a massive amount of pressure is going to be applied to it. And now that refrigerant is going to go and switch from being 0 degrees to being like 80 degrees. And it's going to be brought into your house, and then some sort of fan or some sort of blower motor is going to be blowing over this 80-degree refrigerant inside of a copper pipe. And then your home's going to migrate from being, say, 69 degrees to being up to 70 degrees. And now let's say the 75-degree refrigerant is going to flow back to the outside. The pressure is going to be removed. And now this refrigerant is going to be like -30 degrees again. And this cycle just happens over and over and over again. And that's how we are going to be heating and cooling our homes in the future, most likely. But that's how I'm heating my own home now. And a lot of other people are as well. So this slide is one that should get a lot of attention. So it says cold climate air source heat pumps. So what this means is there's two different types of air source heat pumps. There's standard air source heat pumps, and then there's cold climate air source heat pumps. And the big difference between the two is like a standard air source heat pump, which would have been what was out, say, 10 years ago, and they still make plenty of them today. What will happen as the temperature drops outside, say as the temperature falls below freezing, that heat pump is going to lose a good portion of its heating capacity. There's companies like Mitsubishi, Fujitsu, LG, Daikin. A lot of these are Asian manufacturers. They have a type of a heat pump that as the temperature drops, it doesn't lose any of its heating capacity until sub-zero temperatures. So cold climate air source heat pumps is like all that we would need to be thinking about or worrying about to get residents in Melrose off of, say, fossil fuels. Say we lived in like Juneau, Alaska, or like Fargo, North Carolina. The narrative is not so easy over there because in those climates, sub-zero temperatures are a daily occurrence. But for us, the equipment that's available today, it really can be meeting 100% of our home's heating needs. And we don't need to be thinking about maintaining a fossil fuel-based system unless you're wanting it, because say like resiliency and redundancy is like part of the scope of your project. So whenever I'm talking to people, I'm 95% of the time going over like the benefits of a cold climate heat pump and just trying to like assure people and showing like submittal data like, hey, this actually will be working for your home and you should feel confident in the equipment as long as it is sized and designed properly. So let's just go and start talking about the different types of air source heat pumps. So if your home, which only probably about like 50-ish% of homes in Melrose have ductwork, but if your home does have existing ductwork, it likely is going to be a one-for-one swap where you can be pulling out your oil or your natural gas-fired furnace, and you can be putting in an air source heat pump. And it's a straightforward project. It performs a little bit differently in terms of, with most heating systems, they turn on, 100-degree air is pumping out of them, the like room dries out, and then it reaches the temperature set point, and then it flips off. With an air source heat pump, the air temperature coming out of the unit will be like 80-ish degrees, and it'll be more or less running continuously throughout the day. So do know that it does perform a little bit different. And but when a home is ductwork, whether it's for a gas-fired furnace or whether it's a central AC, it really is a one-for-one swap where you could be dropping in the air source heat pump. With that said, there are different types of ducted systems that are worth knowing about. So let's just say hypothetically that you did have a natural gas-fired furnace down in the basement. Then what my mouse is hovering over on the right-hand side, you could be putting in this type of equipment, which would be called like a centrally ducted system or a high static system. And this is going to be a system that is going to have enough heating horsepower to cover an entire floor or multiple floors, depending on like how energy efficient or how tight your home is. There's another type that's called slim duct, or sometimes it's called low static or medium static, where that type of equipment is really much more designed to be heating, say, a room or 2 rooms, possibly 3 rooms. And this is often, this equipment is often proposed when someone's wanting, say, 2 separate zones. So even if your home is, say, a forced hot air system and it's a 2-story home, oftentimes installers will be like, well, let's use the ductwork for the first floor, leave that be. And for the second floor, let's put in a new system up in the attic and having registers dropping down through the ceiling. And now the first floor, as well as the second floor, can be controlled independently. So you don't end up with, say, a system where it's a good heating system on the first floor, but a lousy central air system on the second. So sometimes people, when they are pursuing heat pumps, ducted heat pumps, they are pursuing the project to solve a potential comfort issue, provide delightful AC, as well as migrate away from fossil fuels. Now, this one says when a home lacks ductwork, you could be thinking about ductless equipment. So say for my home, you could see a column radiator behind me. So I was in this situation. So in my budget at the time, I didn't feel like it allowed for me to be putting in multiple ducted systems for my home and somewhat complicated roof line and dormers. So when a home lacks ductwork, what you could be thinking about is called a ductless mini split. So instead of having a unit and ducts splitting off of it, what you end up happening is the outdoor unit that's connecting directly to something that looks like this. And this type of equipment can either be mounted on the floor or it could be mounted up on a wall. And the advantage with this type of equipment is you put it in a room and it is going to get that room, say, 10 out of 10 comfort-wise. You could be putting it in a room and you could also be sizing it to heat an entire zone. So for example, let's say that you heated with a wood stove, or you heated with a pellet stove, or you stayed somewhere that they've heated with a wood stove or a pellet stove. You're used to probably the phenomenon where it's like, if you're in the same room as the wood stove or the pellet stove, it's hot. And as you move further away from it, it could be eventually become comfortable. And maybe you get so far away from it, it could become uncomfortable. That's kind of a good analogy for thinking about ductless mini splits, because you could be, say, just putting one of these in a room, So you put it in the great room, that one unit could be covering the great room, it could be covering the kitchen, it could be covering the dining room. These come in different kind of capacities, so you can be sizing it to be like putting in one unit and using it to condition multiple rooms. So that's a really great way to be potentially decarbonizing your home and keeping project costs down. We'll talk a little bit more about this, but do know that, say, if you are meeting with contractors and they're talking to you about putting a ductless mini split in every single room where you have, say, a radiator or a register, it's likely going to result in, say, equipment that is not going to be performing properly. Because for a lot of homes, this equipment has way too much heating capacity than, say, a 12 by 12 bedroom. So that's something that we'll talk a little bit more about, but it's worth mentioning right now. So as I'm looking at the equipment, I have examples of the different models that are kind of out on the market today. So the wall hung units are the most popular. We see these getting installed the most often. And the main reason for that is they typically have the best performance out of all of the equipment. It's very easy to be installing these along exterior walls. The one that I like the most, and this is a picture of what's in my house and my foyer, is a floor mounted unit. And a few reasons why I like these ones is, say if it's on a first floor, you can drop all of the line sets down through the basement and run them out the outside of the home. So you don't end up with these kind of gutter looking covers protecting the line set, potentially like affecting the original architectural characteristics of your home. So the floor mounts are really nice because you just drop the line set straight down through the basement outside of the house. Other things that I like about floor mounted units, and I think if you are interested in ductless, you should be inquiring about floor mounts, is that one, it's easier to change the filter, and two, we're in kind of a heating dominated climate. And there is a real argument that having something down low blowing out heat or something up high blowing out heat is likely going to probably lead to better overall comfort. The last one that we have in terms of our ductless equipment is the ceiling cassette. And there's really only one manufacturer that makes ones that can kind of slot into most New England homes framing. Most of the manufacturers that make ceiling cassettes, they're 20 inches wide by 20 inches wide. And most framing is 16 inches on center. So unless you have, say, a carpenter that you would like to bring in on the project, or it is a remodel or a renovation, ceiling cassettes rarely get quoted in Massachusetts. So with kind of covering all of the options, let me just show you. So I could, sometimes when I'm presenting this, we have examples of what not to do. Here's just going to be an example of like what, what to do, okay? So over here, this is an example of like a 2-bedroom condo, but we could just be doubling this if it was like a 2-story home, but like this is what a good heat pump design looks like. So say that you got a common area, so like living room, dining room, kitchen, just putting in like one ductless unit that's sized to meet 100% of that heat load is going to likely be extremely comfortable and extremely affordable. Say if we do have bedroom 1, bedroom 2, as well as a bathroom, instead of thinking about like putting in a ductless mini split in each of the bedrooms and not having, say, any sort of heat inside of the bathroom, like a much better thing to be pursuing with a contractor would be just putting in what's called like the slim duct system, where either down in the basement or up in the attic, you're just putting in this slim duct system and you're just dropping supply registers down to each of the different rooms. When you do that, what you end up with is a system that's just going to be gently adding in energy throughout the entirety of the winter and just gently removing heat and gently removing moisture all summer long. And it's just going to feel absolutely great inside of there. I kind of skipped over like what inverter driven means or what modulating means in terms of heat pumps. But just know that, say, like if you were purchasing, say, a central air conditioning system, like the worst one is a single stage unit. The better one is a two-stage unit. The premium one is the multi-stage system. And the best one that they sell on the market is like an inverter-driven modulating central AC. That's the type of heat pump equipment that we're typically talking about. So it really does lead to kind of the best overall comfort if properly designed. So I think this is when things are going to get good as far as the presentation goes. So this is a personal anecdote because this is my house. And when I bought the house 2 summers ago, there was not a drop of insulation inside of the walls. Pretty much all of the windows were all single pane with triple track storms. The attic didn't have a properly aligned thermal barrier. The home was using a massive amount of energy. And there was also a steam heating system, it's still there, down in the basement that was heating up these cast iron radiators behind me. So when I bought the home, one of the first things that I did is I did what was called an accurate heat load calculation. And this heat load calculation is also referred to as a manual J report. And what it did is when I put in all of the characteristics about my home, all the square footage, measured all of the windows. It's a bit of work, but I'm glad that I did it because I ended up with a number of 108,000 BTUs per hour. And what that means is, say if it is the design temperature outside, which in Leominster, it's 2 degrees, I would need 108,000 BTUs to go from 2 degrees to 70 degrees every single hour. That's how much energy my home is losing through its walls, through its windows, through its ceiling. So what I need is a system that can replace all of that energy that's being lost. And when I went and I looked down on my steam boiler, I ended up seeing that that boiler could provide 129,000 BTUs per hour. So 129,000 is slightly bigger than 108,000, so my home would heat. Say if it was a polar vortex that hung over Leominster and is negative 15 degrees for 72 hours in a row, this steam boiler would still be running, it would still be operating, but I wouldn't be able to maintain 70 degrees. So this is going to be like a key concept as you are thinking about heat pump sizing in a second. But let me go back. So with my home, and this is what Homeworks is out to do as well. I didn't want my home to be performing. I didn't want to size my heat pumps to be for my home as is. I wanted to be designing the heat pumps for the home as it should be performing, which is still we're going to go over a lot of improvements, but just put these in perspective, like where Mass Save is trying to improve a home to versus like where a new construction homes like energy requirements are. Like Mass Save is an absolute no-brainer because it's like it's getting a home good, but it's still not perfect. So do know if you do have a newish home, the narrative is going to be even better than what I'm talking about. But so I took my uninsulated walls, I packed them full of insulation. I took my poorly insulated attic, I aligned the thermal barrier correctly, and I filled that with insulation. I tightened up wherever I could along the house, and I did things outside of what the Mass Save contractors would normally do. And they also upgraded all of my non-architecturally important windows to high performance windows. And when I did all of those things, what ended up happening, instead of needing a heat load of over 100,000 BTUs, my heat load fell to less than 50,000 BTUs. So all of those improvements, insulating the walls, replacing the windows, properly insulating the attic, sealing up the home, it cut the heat load in half, which is remarkable. And what that allowed me to do is, instead of buying 100,000 BTUs worth of heat pump equipment, I could just go and I could just buy this one piece of equipment. And with this one piece of equipment, this could support up to 8 indoor units, and it can provide 54,000 BTUs per hour, which is greater than what my home would ever need. So in addition to like, instead of needing to buy $40,000 worth of heat pump equipment, instead I could buy $20,000 worth of heat pump equipment. Instead of my home last year costing $3,200-ish to heat, it cost $1,600 to heat. And then the other thing, this goes back to what Martha said, there's a lot of initiatives that are going on right now in Melrose. So let's say that you want a level 2 charger and you have 2 huge heat pump systems, you're probably going to now need to upgrade your main electrical service coming into the home. Or say that you wanted to get a heat pump hot water heater and you were filling up 80 amps worth of space on your main electrical panel. Putting in a heat pump hot water heater is probably not a likelihood unless you're now upgrading your main electrical service coming into the home. So there are other like ancillary benefits that are real with shrinking down the load and right sizing the heat pump system. Some other considerations. So this is always a tricky one, but it says move to 200 amps. So let's just say that your home is originally heating with natural gas and you had gas water heater, gas heating system, gas stove, gas dryer. It's likely that the electrical service coming into the home is 60 or 100 amps. There is a possibility, depending on what the load is of the home, that you may need to be upgrading over to say 200 amp service. And upgrading over to 200 amp service, depending on the electrician, that could be incurring an additional like $3,500-ish to the project. So do know that upgrading electrical may be part of a heat pump project, but that investment will also likely enable you to eventually put in a level 2 charger for your EV, consider heat pump hot water heaters, put on an induction cooktop. So it's not as if that the only reason that you would ever want to be doing this is just for a heat pump. It is also just for potentially future-proofing your home. Heat pump dryers, they're real. They really work. Induction stoves, pretty much everyone who's migrated over to them from a gas cooktop thinks that it is a far better solution for cooking. It's wildly safer. It's wildly safer. So much less pollutants entering into your living space. And then heat pump hot water heaters is a really good solution for a lot of households. And I think that Martha, let me know, with the Heat Smart campaign that you ran, you were also promoting solar thermal or solar hot water as well?
Solar hot water and ground.
Okay, yeah, and then the other, just going on with these other considerations regarding electrical, next year Mass Save is finally going to be doing a rebate for solar hot water systems as well. So that's something to totally be thinking about or looking at if, say, a heat pump hot water system doesn't appear proper for your basement. But that's a whole other webinar. So let's just talk about going back to rebates. Let's just go and talk about what Mass Save did in 2022, and it's phenomenal. So let's say in 2021, you're heating with natural gas, you got a $250 rebate per ton, and my home needed roughly 4 tons, so I would have only gotten a $1,000 rebate. What they switched it to for gas customers and oil and propane customers, it's now a flat $10,000 rebate for putting in whole home heat pump systems. So if you're ready to migrate away from fossil fuels, go all electric, it'll be a flat $10,000 rebate. It goes a really long way and for most projects. Say if you're not ready to migrate completely off of fossil fuels, and it could be because you just put in a brand new high efficiency natural gas furnace 3 years from now. And what Martha said as well, it's like Melrose has 2050 climate goals. There's nothing wrong to also have 2050 climate goals. Like we don't need to be ripping things out. We just need to have a plan. But say you put in a high efficiency natural gas fired furnace 2-3 years ago, you could just be putting on a heat pump literally right on top of it. And if that was the approach, you'd likely be displacing about half of your natural gas use And Mass Save is going to reward that kind of partial step with a partial home rebate of $1,250 per ton. So that could be a really good approach. Or let's just say that you did have significant comfort issues upstairs and downstairs, fine. You could just be putting in, say, 2 ductless mini splits upstairs. You have delightful cooling. You're not needing to run the heat up there anymore. You're going to get rewarded from that too, as far as Mass Save goes. The other thing too that I haven't talked at all about, and I should, is there's also ground source heat pumps. So that's a geothermal system where it's extracting energy from the earth versus the outside air. And when you do that, there's a couple benefits of it. So like benefit number one, if there's a snowpocalypse or if there's ice storms or a polar vortex, you don't need to worry about the outdoor equipment. And then the other big benefit as well is there's no outdoor equipment to be looking at outside. And the best benefit from someone who's like nerdy about energy efficiency is the ground temperature is about 45 degrees. So it's a lot easier for a heat pump system to extract energy from 45-degree air than 5-degree air. So the efficiency of the equipment's a lot better. So do know that geothermal projects come in at a bit of a premium. So Mass Save is putting a slightly better incentive on there. So it's $15,000 for putting in a whole home geothermal system. And with geothermal, I've never seen a partial home system, but you could also be doing that. But if you're paying to do the geothermal, you might as well just, there's very little benefit of maintaining the fossil fuel-based system with that efficient of a heat pump. So some of you may know that in the Inflation Reduction Act that a lot of climate things got tacked onto it, which to me is great because it really does help out with the affordability right now. Do know that things are kind of happening in phases, but for all kind of like non-moderate income, non-low income households, the federal tax credits are going live January 1st of 2023, and it'll be a flat for cold climate Energy Star heat pumps. It'll be a $2,000 tax credit. And going back to this whole home versus partial home, it is going to be a tax credit that you're going to be able to take advantage of year after year. So there could be a real opportunity to be, let me decarbonize the first floor this year and let me decarbonize the second floor next year. So this is something that could even be happening in stages. There's also money that will be available to help with cost a $600 tax credit for upgrading your main electrical panel if it is going to be tied to, say, a heat pump project or putting in a level 2 charger for an EV. And then later on next year, likely in the spring, there'll be some more guidance as far as what will be offered for low and moderate income households, but it should be very, very favorable. So let's go over what some of these kind of services actually look like. So this is the landing page, and if you scroll down on the landing page, you kind of hit, you'll eventually see something that looks like this, where there's 3 different options. So option number 1 is I'm thinking about heat pumps, but don't have quotes yet. Option number 2 is I already have quotes from an installer. And then the third option is I'm looking for technical guidance on heat pumps and more. So with the first option, if you click that box, what it will do is it opens up this. And it just has all of the availability that all of our consultants that are part of that team have. So you just click on, and it doesn't look that favorable because we're approaching the holidays and like pretty much everyone's off the week after Christmas. But on most times there, you see a lot more availability. But you click the time, you click the date, you click the time, you push next, you put in your name, your email address, and then you hit submit. And then it creates a Zoom conferencing link that you and a heat pump consultant will spend up to an hour to be working through your project. And after that hour is up, the consultant goes and sends a follow-up email so you have concrete notes about what this all looks like, as well as some really great resources. So we could also highlight on the webpage that there's like participating contractors that you could like go and punch in the zip code and see all the contractors working in your area, I would strongly suggest, well, you can start with finding a contractor and having them out to your home first. This is a service that's already kind of bought and paid for the residents, and we will make sure that you're kind of on the right track as you are meeting with your first contractor. The second option is, let's say that you've already had a consultation, or let's say that you have pursued heat pumps before, you got a bunch of quotes and you don't know what to do with it. This is our second option, and this is called the quote comparison report. And we spend we in-house we spent many hours creating a super nerdy kind of like calculator that overlaps how your home's performing with how different heat pump equipment is performing. So we dive into kind of manufacturer submittals. We plot how the home is using and losing energy throughout kind of the course of the entire temperature spectrum. And then we plot how each heat pump equipment combination is performing across that spectrum. And it does a really good job of predicting like which of the different proposals is going to lead to the best performance in terms of heating, in terms of cooling, in terms of carbon, and in terms of cost, as well as just clearly outlining exactly like, what are you paying for? Because if you do look at some of these HVAC proposals, some of them give a 14-page proposal when like it just seems like it's junk, and some people put like 3 lines on their proposal and it doesn't seem like enough information. But we'll get eyes on all of the quotes, think about them critically, and then just think about how the performance of the equipment really does overlap with your home. So this is like, it's a really valuable service. And the last thing that I want to just talk about before questions and answers is this. So I do heat pump consultations throughout everyone in Massachusetts, like our retail services stretch throughout the entire state. And I will say, so most people in Massachusetts this upcoming heating season, they're likely going to be spending somewhere between like 35 all the way up to 45 cents per kilowatt hour. With Melrose in your community choice, your like clean energy aggregation program, or even the baseline where it's not that much cleaner than what you would normally get through the supply of National Grid, it is a total game changer in terms of operating costs, what people are going to be spending this upcoming winter. So right before this webinar, I just went in and I plugged in kind of Melrose's rate, and I plugged in what people are paying for natural gas this upcoming winter, which is about $2.50 per therm, all in. And this is what the calculator had. So right now, if you're just looking and thinking about like, with my utility rates, how much am I paying? And there's a lot of variables in here that are not covered that could be tweaked for every home, because every home is somewhat specific. But like the narrative is, it's like heating with wood is the cheapest. Most people in Massachusetts, especially in an urbanish environment, shouldn't be heating with wood. The next cheapest would be ground source heat pumps, geothermal. Then we're back to heating with wood again, this time with pellets. And then the next cheapest one would be ductless mini splits. And then after that, it would be natural gas. And then just things go up and up from there. There's certainly ways, like if I had like an engineering person on here, it's like, well, if I have a 97% efficient natural gas boiler and I have a very poorly designed ductless mini split system, like these numbers would be flipped. And I agree with that statement. But for most people, really the narrative that I think every resident should be thinking about is like, because people like Martha have worked with the DOER to set up this clean energy community aggregation program, it just makes the adoption of air source heat pumps so much better, because you're not paying a price premium whatsoever for clean energy. So it's something that I just really, I wanted to highlight, because any of the towns that have set this up, it just really does make it so much of a no-brainer, where it's like, quote unquote, like doing the right thing, but also paying less to do it. So that's everything that I got. I'm happy to be on questions and answers for as long as as long as people want to talk for.
Mike, that was really great. Thank you. I learned something new every time I listen to one of your presentations. So I really appreciate that. I, for some reason, do not have a chat function. Do you guys see a chat function?
No.
Yeah, it's odd. I don't know why. So I think the best option then is if you could, if you want to turn your video on and raise your hand, if you go to reaction and raise your hand, if anybody has a question, Mike can answer it. But while you're gearing up your questions, if you're not currently enrolled in Melrose Community Power, you can look at your most recent electric bill and see where it says, supplier on page 2. And if it does not say, if it says something then other than Next Era, our supplier, you're not enrolled in our program. So you can enroll in the program by just Googling Melrose Community Power. The other thing is that Mike went over the new incentives that will be in tax credits that will be coming out in 2023 through the Inflation Reduction Act. And there's also a really handy, fantastic calculator that there was a link to it at the bottom of his presentation that said, it's rewiringamerica.org. And they have this great calculator where you can put in your household number, your, our zip code, number of people in your house, how you file taxes, your income, and it'll calculate all of the incentives and tax credits that you're eligible for starting in 2023. So it's pretty robust, pretty amazing. So let's go to Liz, and you can just unmute yourself.
So I'm no longer in Melrose. Do you know if there are tax credits similar in Malden? And also, if you don't go to electric for your stove, are you still eligible for the whole house heat pump rebate?
Yeah, so with the with the federal tax credits, it's throughout the country, and with Malden, it's also a community that's paying into Mass Save through the utility, so you're eligible for all of the same rebates and incentives that a Melrose resident would be. The only difference is, say, with the no cost consultations and things like that, you wouldn't be eligible for. One thing that I didn't say is, so as far as with the $10,000 rebate, you don't need to be decarbonizing your home to get the $10,000 whole home heat pump rebate. What you need to do is you need to size a heat pump system to meet 100% of the building's heat load. And you don't even need to be ripping out your existing distribution system or your existing heating system. So in 2022 into 2023, there's a sign off that you would check and you would sign and your installer would sign that says that I'm just using my existing heating system in case of emergencies or downtime. So there's no getting around that. There could be a hypothetical where there's 6 feet of snow that falls overnight and the outdoor unit is completely encased with snow. And then at that point, yeah, it'd be nice to not need to think about waking up and like shoveling out the outdoor unit before it's encapsulated in 6 feet of snow. But if that doesn't happen, there could be a benefit of having an existing heating system being left in place. So it's all like very much a hypothetical, but that's kind of how Mass Save is structuring things right now. And if anyone is very much concerned about what I just said in terms of like resiliency and redundancy type of topics, I'm more than happy to like continue that discussion of like what that could also look like without needing to be thinking about maintaining a fossil fuel based heating system, because there's a lot of other workarounds too.
Ellen?
Hi, thank you. This is a really great presentation. I guess I'm in that category 3 in terms of not planning to do anything immediately, but I've really been thinking about how can I start thinking about a pathway to decarbonize my home.
Yeah.
And in terms of also looking at some of these options for partial homes, because it might help with comfort issues. So I guess the question is, can you post the website and then how to sign up for these you know, any of these appointments.
Yeah, certainly. I
Had a
have someone
visitor.
who's joining the webinar.
And let me just, I have, I've all of you registered for this with your email addresses, so I am sharing his presentation, and I will also share links to the Abode homepage, as well as the Rewiring America page with all of you, and also all of the participants from the workshop tomorrow.
That's great. Thank you.
John, did you have a question? You need to unmute, John.
Can you hear me now?
Yeah, we can.
Okay, Mike, I got a quote a few weeks ago, and it was kind of at a lock. I wasn't sure what I was going to do, and I was actually talking to Martha on the phone yesterday. But one of the questions I have is, it looks like you have 3 potential meetings you could set up, but I'm really not prepared for that second meeting. But if I have that first type of meeting, does it preclude me from having the second meeting?
No, yeah, it's all open-ended, and I didn't talk specifically about the third option, but that's like, I'm trying to do something and I just need to talk to someone who's like building science and mechanically minded. Yeah, so that's like that consultation's typically landing in my calendar.
Okay.
Yeah, so for kind of those tricky ones.
Can I send you emails like questions or whatever at the site?
Yeah, so I always recommend first starting off with the consultation.
Okay.
Can I do the words for you?
Okay.
Can you whisper them in?
Okay, I will be back in like 10 seconds.
Okay.
Miles, you want to say goodnight to everyone?
Good night.
Okay.
Good night, Miles. So yeah, and the other thing I want to say while Mike's putting Miles to bed is that the services that Abode is offering are all free to Melrose residents. We're using a grant to fund. So when you bring up that page of the quote comparison tool, there's a line there at the top that indicates that it's $150. But if you put our zip code in, the fee's not charged.
Okay. So Martha, can you hear me still?
I can't.
Yeah. So I guess he's going to come back, but my question is, are you allowed to have more than one consultation with these people?
Sure.
Okay, you are. That was because, I'm kind of like in a level, I wasn't sure where I was at. Plus I have one other question for him. If he can,
10 sessions, John, might be a lot, but we'll give you 2 or 3.
No, that was the whole thing. I wasn't looking for 10 sessions. The other thing is, it's like you mentioned the mini split and the full split. I actually mentioned to Martha, I have a split entry house.
Yeah.
And the contractor says, if you do have a split entry house, it makes it a little bit more convoluted because it's a finished basement. And he kind of suggested, I do have central air, but I have oil heat on the baseboards that to go with the regular ducts on the first floor, and then in the basement to kind of go with the mini split.
Yeah,
And I'm sure, but it's kind of like one of these things, because he says that it would cost a lot to put the ductwork in. So I guess it's like, I'm almost thinking of getting like multiple quotes, doing multiple different things and having you guys look at it.
Yeah, that's it's like, it's always tricky because say if you have existing ductwork and there's ductwork running into the basement.
No, the ductwork's not running into the basement.
Oh, the central AC's in the attic dropping down.
Exactly. Yes.
Yeah. Yeah. And sometimes it is a matter of like there does become a question of like, say, does it make sense to be potentially like losing closet space of the second floor and running ducts down, versus just spending $4,000 or $5,000 and putting in a ductless mini split. So yeah, we're used to those conversations and just trying to get them. And then there's just another question about zoning between floors, because basements have wildly lower loads than first floors would. So sometimes just putting in the mini split and not worrying so much about the duct design is usually the more comfortable option. But at the same time, there's lots of people that don't want to be looking at a ductless unit that may be hanging off of their ceiling. So
But
we're ready to.
if you go to a situation like that you go with the ducts up top and the mini split in the bottom, does that preclude you from getting the $10,000 rebate?
No.
Okay.
Yeah. No, mix and match. So with Mass Save, all the equipment needs to be on the Mass Save heat pump qualified product list. So as long as all the equipment's qualifying and it's covering kind of 100% of the building's heat load, you're good to go with the $10,000 rebate.
Yeah, and one other comment about the contractors, and we'll go to your question, Janine, is that starting in 2023, in order to be eligible for the Mass Save incentives, you have to use a contractor that is on their heat pump inspector network, their list. But Mike, all of your vetted contractors on the abode site are they all also on the Mass Save site?
Yeah, and it is a really low lift as well for contractors to get approved. So let's just say that you've built a relationship with a plumber or an HVAC company for the last 20 years, 30 years, and like you want to be working with them on the heat pump project because you trust them with everything that you've trusted them with everything in your home. I'd be more than happy to be, sending over what they would need to be doing to get onboarded with the Mass Save. So that's like something that I do maybe like once or twice a month is, just trying to ensure that that's good to go. Because right now it wasn't a requirement, but it was a requirement for financing. But next year it's starting off a requirement for financing and for rebate eligibility.
Oh, and okay, Janine, we'll get to Janine's next and then Rebecca, but also the 0% heat loan so once you have your home energy assessment with Mass Save, you get an intake form during that assessment, and you can use that intake form as your ticket to accessing the 0% heat loan. It's offered in Melrose at Eastern Bank and at the Metro Credit Union down by Pine Banks. And it's 0% interest over 7 years up to $25,000. So it's a great way to finance and fund your project.
Yeah, and you can also use it for up to $5,000 for upgrading the main electrical service and panel as well. And just the other high level concepts of the heat loan that I think is valuable is like, your money can always be doing something better for you today than buying HVAC equipment. So I do think that even if people have some level of sensitivity towards loans and debt and things like that, like it really is 0% interest and your money can be doing something better for you. And then the other thing that I like about the heat loan as far as a mechanism in the Mass Save program is it gets eyes on the project before applying for the rebate. Because the worst thing ever is applying for a $10,000 rebate and you find out that one of the 3 pieces of equipment that you put in or your installer put in that said is rebate eligible is not actually rebate eligible. And then Mass Save is like, nope, no $10,000 rebate. We can just give you a partial home rebate because not all the equipment meets the minimum efficiency standard. So with pursuing the heat loan, it gets eyes on the project before anything's installed. So then you can feel a lot more confidence kind of moving through the process.
All right, Janine.
So I really like the fact that you brought up with the radiators, because I got a couple quotes and I was asking about that, but they kind of steered me saying, oh, no, you want to go with the wall ones, they're more efficient, they're cheaper, but I don't like the wall mount, but also I'm less concerned about AC and more concerned about heat, and it just naturally seems to make sense to have it down where you're going to be sitting, Can you tell me, having it in your house, is it more comfortable for heating down where you're sitting and, walking? And also, do you find it's just as efficient as the wall mounted?
Yeah, so with the difference if it's on there's a lot that I didn't cover, but on the outdoor equipment, there's single zone where it's one outdoor piece of equipment talking to one indoor piece of equipment. And then there's multi-zone. So one outdoor piece of equipment talking to 2, 4, 8 pieces of indoor equipment. if the indoor equipment is tied to the multi-zone, that's what's going to dictate its performance. So there's no difference in efficiency between wall hung or floor mount or ceiling cassettes. The single zones, where it's one outdoor unit, one indoor unit, all the latest and greatest features and the highest SEER rating, like the cooling efficiency or HSPF, the heating season performance factor, which is the heating efficiency, that stuff all looks better with the wall mounted than the floor mounted. So for most households, there's really not, because most of the time people don't want 5 outdoor units. They just kind of want 1 or possibly 2. As far as comfort goes, my perspective is it's somewhat subjective. Because kind of going back to, like, there is lots of people in New England that are perfectly fine with a wood stove, and it's one emitter heating an entire home, and that's comfortable for some people. But other people, it's like they do want to have a register or a radiator or a vent in each and every room, and that's the only thing that's considered comfortable to them. What I can say is, with a well-designed heat pump system, whether wall mounted, floor mounted, or ducted, it should be if not more it should be more comfortable than your existing heating system, unless you're making concessions. So for example, I made a concession to keep my budget down, and what I more or less did is I sized my system for every other room. So for example, there's one in my kitchen, there's not one in my dining room. There's one in my foyer, there's not one in my living room. So one room's 70 degrees, the other room's 68 degrees. And if I did more energy efficiency improvement, then maybe that room would be like 69 degrees. So it's just a little bit different in terms of like what to expect and what your goals are for the project. Other things to be keeping in mind, it's like you could just be putting, the ductless mini split, one ductless mini split, that's all that you can afford. You just put in your favorite room where you spend the most amount of time, and you get that room 10 out of 10 comfort wise, displace a lot of fossil fuels, and then the rest of the house could be heated with the existing system. So there's lots of flexibility with design.
We were talking about a 2-zone system, so 2 units outside, and but he seems to think that if I went with the floor mounted, I would need more units in the house. And I do have radiators in every room, but I don't think I need, from what the air is supposed to flow. And I know if I use electric heat, which I have in some rooms that are just wall electric heat where it blows, and it slowly as long as you keep it on, it migrates to the whole house. In a sense, I really only have to heat the first floor, and it just goes up to the second, just naturally. But I don't suffer from, I don't notice the heat in the summer so much, but I do notice the cold. So, I'm very sensitive to that, so would it make, do I need to think about having more units downstairs to do the same thing as a wall mounted, or do you think?
You don't need to, so there should be, with floor mounted or wall mounted, how everyone should think about the equipment is really just in terms of its capacity. So they make a floor mounted one that's 12,000 BTUs or 15,000 BTUs or 18,000 BTUs, and they make wall mounted ones that are 6,000 BTUs, 9,000, 12,000, 15, 18. So it has the same amount of heating horsepower or heating capacity. But every home's different, and then just sizing the equipment for the zone, that's really all that you need to worry about. But one thing that is important to know, if someone has column radiators or baseboard radiators, like these are forced hot air systems, so they're not just radiating, but they're also convecting. So they're also just pulling in air, conditioning it, pushing it out. So they do cover more than what, say, like your existing emitter or heat source likely would be.
Okay, so it would flow like what I sometimes have when I use the wall, forced air that just pushes it out, because, otherwise when I'm using oil, I'm using steam radiator. But that's good to know that you don't seem to have extra layers on too much there.
No, like with my own, and every home's different, but like with my own home, I hit my first floor of the original part of my home, it's 1,000 square feet. I have 2 ductless units,
That's
so
it.
it's like,
Oh, wow. Because he was talking about, I have a total 1,000 square feet for my entire house. And he was indicating 2, maybe even 3 on the first floor.
Yeah.
I went with, wow.
Yeah, and it's like, you know, the comfort is subjective. There's a lot of things that determine what is comfortable or not comfortable, including like, what is your windows, what is your metabolism, like how old you are, like what is your weight, what is the temperature of the surface areas all around you, what is the air temperature. So there's like, there's definitely situations where, you know, you may be needing or wanting many more units than say 2. And then the other just general trickiness of this as well is, say with HVAC installers, they do have, say, an incentive in terms of commission with likely installing more equipment and not less equipment. And they also have an incentive in terms of minimizing callbacks with putting in a system that may have a lot of safety factors built in. So there's lots of these conversations that I have, or consultations where I have, where someone wants 6 units and I'm like, no, you get 4 units, and you need to figure out, we need to come up with clever ideas as far as how to spread them out, because if you put in 6 units, the equipment's going to be really oversized and it's going to do a horrible job with managing humidity in the summertime. So there is a consequence in terms of comfort with oversizing equipment. And then there's other consequences too. Like, one, it's going to cost $10,000 more to purchase. And then the other thing is it's going to cost hundreds of dollars more over the course of a year to operate, and thousands of dollars more over the lifespan of the equipment to operate.
Oh,
So
yeah, because
some of
his
these,
Yeah.
concern was, I
Janine,
have this, one last thing, Martha.
Yeah.
I have the stairs down the middle. It's tiny house, right? And then the kitchen is off to the side, but only has the doorway. It has a door arch, and he just felt they all seem to feel like the air wouldn't flow, you know, into the other areas. So that was the concern that they all seem to throw at me. So
great.
Okay.
All right, Rebecca.
Martha. So actually, just a really quick question. Great presentation, by the way, really interesting. Definitely want to sign up for the option 1 consult, I think. But can you explain a little more about the per ton for was it the partial home thing? I don't understand how that calculation works.
yeah. So and I will say that I probably should have explained what a ton was before using it, but it's widely used. And it's the term ton is often used with cooling systems. And it's a legacy term because a ton of ice, which we used to do in New England, we would be shipping ice by the ton, would be removing 12,000 British thermal units every single hour. So let's just say you have a 2,000 square foot colonial. Traditionally, a HVAC company would be like, yeah, let's put in a 3-ton central AC to cover that 2,000 square foot colonial. So let's just say that person, instead of putting in a central AC, put in a 3-ton central heat pump, it would likely be a $3,750 rebate. So now what that would look like is you would have a piece of equipment, a heat pump, where it would be meeting a portion of the home's heat load. So let's say anytime that it's above 30 degrees, the heat pump system would have enough heating horsepower to heat the home from 30 degrees and bring it up to 70 degrees. But below 30 degrees to 0 degrees or -5 degrees, that's when your fossil fuel-based heating system would be taking over. So for some people who are just kind of looking to kind of take a baby step or a big step over to heat pumps, like the partial home solution may be the more appropriate of the 2 options. But earlier today, I had a consultation where it was a 3-story home, gas-fired furnace with central AC down in the basement. And the 3rd floor was boiling, was always super hot in the summertime. So like this customer could be putting a heat pump up in the attic, dropping down to the 3rd floor, and end the project there and just claim this partial home rebate. And now they're third floor is its own zone, and the first and second floors using the existing natural gas-fired furnace with existing central AC that's only a couple years old.
Yeah.
So that's kind of where the customer
Yeah.
market would be for these partial home solutions.
Yeah, we're one of those people who put in the high efficiency natural gas probably 3 or 4 years ago, and now are like, oh, why didn't we think about heat pumps at the time? But we
Yeah.
might not have gotten as good a solution as we could get now. But so are we committed enough to, reducing carbon to just sort of say, all right, well, just forget the money we spent on that 3 or 4 years ago. Let's do a whole home.
Yeah, and I always remind everyone, we do have 2030 climate goals. Like, it'd be nice to have 2023 climate goals, but there's lots of other things that we could be doing for the environment and for community other than buying low carbon HVAC equipment. So it's not to minimize, the impacts of heat pumps at all, but like, there's a lot of boxes to check in terms of decarbonizing, so it could be thinking about domestic hot water, it could be thinking about EV charger, it could be thinking about removing removing gas cooktops. So yeah, so there's lots of other
I
things.
call it zero over time.
Yeah.
Yeah.
Yeah, you gotta.
And we've done so. We have the induction cooktop, which is great. Haven't bought an EV yet, so no point in doing an EV charger. But do you consult about some of those other options, or is it really just the heat pump consulting you're doing at this point?
Yeah, so I always have a wide range of discussions, but as far as things that I feel very appropriate with talking about is regarding domestic hot water, heat pumps, as well as just thinking about the building envelope and just making sure that any experience with mass save that you may be having, that you're receiving kind of the full benefits of the program. So there's lots of times where I'll be chatting with someone and be like, well, what about, what do they do in the crawl space? And it's like, oh, they didn't even go in the crawl space. It's like, what? So yeah, sometimes I'm, circling back over on that stuff as well.
Mike, can you take one more question?
Yeah.
Before we wrap it up. Rebecca, did you have anything else?
Nope, that's good. Thanks.
Great, thank you. Mohammed.
Hey guys, good evening.
Hey.
Thank you so much for a great session. And I'm sorry if this has been answered already. I have a 1,500 square foot home in Melrose. We have steam heat boiler, and it's leaking. So we know we need a new one. We just keep adding water to it manually. So we're due for one, but I have, I moved up here from the south and we've used heat pumps down there for a long time and always knew that they didn't work well when it comes to certain cold temperatures. And I replace my gas heat or my gas boiler with a heat pump and not have to worry about needing auxiliary heat from my boilers?
Yeah. So, Mohammed, so other things that I didn't cover in this presentation. Hey, Mohammed. There's central heat pumps, and then there's mini splits. So with the central heat pumps, these would be from kind of all of the companies that traditionally made central ACs as well as gas furnaces. So the names of some of these could be Carrier, York, Bryant, Trane, American Standard, Bosch. So all of these companies have made their name and made their reputation selling, say, a gas furnace with a central AC on top, or a centrally ducted AC. All of their equipment today, and a lot of money is going to these companies to improve the technology. It starts off with plenty of heating horsepower, and then as the temperature drops, the heat pump's capacity drops. And it leads to usually a capacity balance point somewhere around freezing if you're sizing the system to meet 100% of the cooling load. All of that equipment is going to need backup heat, which most of the time, what we see installers doing is they put in an electric resistance coil into the cabinet. And an electric resistance coil may sound fancy, but it's the same thing that's inside of a toaster oven or the same thing inside of a blow dryer. And it's 1 unit of electricity in, 1 unit of heat out, versus the heat pump where it's 1 unit of electricity in, it's like 3 units of heat out. All of the Asian manufacturers, so Mitsubishi, Fujitsu, Daikin, LG, Gree, Cooper and Hunter, like I can keep naming these if it's helpful. They all have a brand of equipment that would be considered like a cold climate heat pump. Mitsubishi calls it Hyperheat, LG calls it Red, Fujitsu calls it XLHT, and that equipment doesn't lose its heating capacity until sub-zero temperatures, which are 32 degrees less than freezing, which we really don't need to worry about in Melrose. So I think, Mohammed, that you could be putting in a centrally ducted heating system, a mini split type of heat pump system.
Yeah, I don't have that work.
Yeah, so a mini split type of heating system in your 1,500 square foot home, and it'll likely be a pretty easy setup, where it would likely be with 1,500 square feet, it's probably going to be a single multi-zone unit. And then it's either thinking about ripping out the steam and putting in ductwork from down in the basement, or it could just be scattering some ductless mini splits throughout.
Okay.
Yeah.
Thank you.
Yeah, just as a note, there are heat pumps used all over Maine. Maine is they're for their heating and cooling, and they work just fine in Maine's cold climates, just as they will do here. The brands that Mike talks about, the cold climate
Just
technology.
out of curiosity, how long has it been since heat pumps have been able to break the 30-degree barrier you always heard about?
Yeah, so like the Hyperheat equipment from from Mitsubishi has been around for the last, say, 10 years. So say before, I assume you were living in a slightly southern state.
South Carolina, yeah.
Yeah, so that they really don't have much, like with those companies, they don't really have much of a presence down there. So it is all the kind of like US manufacturers with that type of heat pump that does have a capacity drop. So it's just slightly different, because say down there where it's a cooling dominated climate, like you're kind of sizing your equipment for cooling and not heating, it's like less needed to be, let's say, paying a premium for a mini split type of heat pump that's cold climate. So it's like with housing, with HVAC, it is very much like regional. And then I will just also say that like the technology was out 10 years ago, it didn't have some of the really great efficiency ratings that it does now. So the equipment's never been better. And there may be some people, just because I think these things normally attract a bit of a climate conscious crowd, do know with the current refrigerant R410A, it's likely not going away in Massachusetts for the next 5 years. It's a much better refrigerant than R22, which put all the holes in the ozone layer that everyone was really rightfully worried about. But there's not like a next generation of heat pumps coming out next year in Massachusetts, or 2 or 3 years from now. It's going to be a much longer process before any next generation of refrigerant gets approved here.
So, Mike, this has been great. So appreciate your time. And I mean, I just learned so much every time I listen to you talk. But I am so thankful that we have a BOD who can do these consultations, and because I do get a lot of calls, and I not anywhere close to the right person for anybody to talk to when they're thinking about all the different options for their home. So we should, be sure to use a BOD services. And the other important piece, of course, once you do install the heat pumps, is operating them. And any good installer contractor will be sure to explain to you, the most efficient way to run and operate them, which is pretty much, from what I understand, set it and forget it. Right, Mike?
Yeah, and even with that, I could go on for about an hour in terms of nuance, but the type of heat pump that Mohammed had experienced before, it is 1,000% true with that, because if you don't set it and forget it, that electric resistance kicks on anytime that you're trying to recover. With mini split type of equipment, it's not as important, but it's probably still a more appropriate way to be running the equipment to get the best performance out of it. But if there is I don't want set it and forget it to be like, does that mean I have to sleep in a 70-degree bedroom? It's like, only if you want to. So you're welcome to play around with it. So it's just a little nuance with the messaging.
Yep, got it. All right, well, thank you very much. And tomorrow, look in your inbox for his presentation and links to all the things. And I'm sorry there was no chat function in this. I don't know why, but I think it's easier to just get it all in one place for me tomorrow. And, you know, reach out if you have any questions. So thank you and happy holidays to all of you.
Thanks for having me, Martha.
Yeah,
Happy
thanks, Mike.
holidays all, and I look forward to hopefully connecting with the majority of you about your heat pump project in the future.
Great.
And if not me, I do have really great colleagues.
Yes, you do. Take care. Thank you.
Thank you very much.
Yep.
Bye-bye.
I know.
Good night.
Thank you, everybody.